Okay, so to wrap up this worksheet, we are looking at a word problem. We have a certain species of bird that's introduced to an area 30 years ago. Oh, look, I've already underlined it because I knew it would be important. Biologists observe that the population doubles, that's important, every 6 years. And its population is now 32,000. Find the initial population. Okay, so doubling. If I am looking at a population that's doubling, I'm going to use my double time formula, and it is conveniently given to me in the problem below, part B. So let's use it. So our population, n of t, is equal to n sub 0, my initial amount, to the power of 2 divided by, 2 times t, 2 to the power of t divided by a. So n sub 0, remember, is our initial amount, and a is our doubling time. So we want to solve for the initial population. That is our n sub 0. So what do we know? Well, we know that doubling time is 6 years. So I'm going to let that a be equal to 6. And I also know that at time right now, which is 30 years since the beginning, the population is 32,000. So I'm going to plug in these values and find n sub 0. So we are going to set 32,000 is equal to n sub 0 to the power, times t. Oh my gosh, I can't talk. 2 to the power of 30 divided by 6. Okay, so 32,000 is equal to n sub 0 times 2 to the 5th. 2 to the 5th is 32. So if I divide both sides by 32, I get 1,000 is equal to n sub 0. So that is my initial amount. 1,000 birds. Oops. If I want to be accurate. All right, so my population, my equation that models this population, all I have to do is fill in my initial amount and my doubling time, which is 6 every 6 hours. So I leave t and n of t alone, leave them as variables because I want to be able to plug in anything for t and get out the population at that time. Okay, so now I want to know what the population will be 18 years from now. Here is a good catch. Now, when it says now, remember the very beginning of the problem, we were told that our population is at 30 years currently, 30 years since it started. So 30 years from the initial population. So 18 plus the 30 years we already have means 48 years since the beginning. Initial should be beginning. All right, so using my equation, I really want to find what is n of 48. So plugging in 48 for my t value, I get 1,000 times 2 to the power of 48. Again, I'm not using a calculator to do this. I can do this in my head. 48 divided by 8. Wow, that was really bad. And I will admit I'm using a calculator for 2 to the power of 8. Because I just don't know what that is. 2 to the power of 8 is 256. All right, so 1,000 times 256, this I can do. 256,000 birds. All right, and let's sketch a graph. So sketching a graph, I'm just going to make this as simple as possible. We'll have time on the x, the population on the right. I know population every 6 years, so let's say I look at 6, I won't even want to go that far. Let's say 10, 20, 30, 40, 50. And my population of birds will go up by, I'm just going to make it super easy on myself, to 100,000 every tick mark. All right, so my initial population is 1,000. So when t equals 0, my population is way down here. When t is equal to 30, my population was 32,000. So over here, I was probably about here. And the other thing I know is that when n is 40, or time is 48, my population is 256,000. So I can really start to see it increase now. So my graph goes pretty flat to begin with, and then it's going to